is a recording for section 1.2, estimation graphs and mathematical models. The first thing that we're going to do is just review about rounding numbers, because in this course, when you're doing your homework, and it asks you to round to the nearest hundredth, you don't want to miss the question because you put 1.1 instead of 1.12, for example. So just a reminder, look at the digit to the right of the digit where rounding is to occur. If the digit to the right is 5 or greater, add 1 to the digit to be rounded. Replace all digits to the right with zeros, right? If the digit to the right is less than 5, do not change the digit to be rounded and replace all the digits to the right with zeros. If rounding to a place value after a decimal point, drop all the zeros at the end of the number. And recall that the squiggly equal sign means approximately equal to, right? You do that when you round. You say it's approximately something unless you have the exact value. Just a reminder about the place value chart. Here's the decimal point, and of course we go ones, tens, hundreds, thousands, etc. this way. But remember that there is no once place. So it's ones here, but the first one is the 10th place. So you kind of associated hundreds with being 3 over, 300. But when you look at the hundredths, it's the second decimal place, tenths, hundredths, thousands. So let's take this number and round it to the indicated place value. So the first, we want to round this to the nearest hundred. So everything before the 100 is going to stay the same. And basically you're trying to decide if this is closer to 6,408,200 or 300. So since we want to round to the nearest 100, we locate the hundredths place, and if the number is greater than 5, which it is, you add a 1 to the place that you're rounding to. You add 1 and you replace the other ones with zeros. So obviously this one is closer to the 6,408,300, which you can kind of look at it anyway and see 265 is closer to 300 than 200. The next one says round to the nearest 10, which is of course this place. That's our tens. It goes ones and then tens. We locate the tens, and the number after the 10 is greater than or equal to 5. So again, you round up, which means you add 1 to you keep everything before that the same. We're rounding to the nearest 10. That's going to go up to 7, and then you replace anything else with zeros, which obviously if you round this to the nearest 10, you're trying to decide if it's closer to the 260 or 270. All right. The nearest 1,000, we go out to here, so everything before the 8 will remain as is. And we look to the digit to the right of 8, and it's less than 5. So we keep our place that we're rounding to the same, and we replace the other ones with zeros. And 10,000 is this place, right? It goes thousands, 10,000s, 100,000. So we're rounding here. So the 6 and the 4 will stay the same. We look at this 0 and we see the number to the right of it is larger than 5. So that means that we're going to add 1 to this and replace the rest with zeros. Million, that's right here. All right. So we basically want to decide if it's closer to 6 million or 7 million, and clearly since it's less than 6.5 million, it will be 6 million. But if we follow our rounding procedures, we see that this is smaller than 5. So we keep the digit we're rounding to the same, and we replace the others to 0. And lastly, 100,000, which is this place. And so we keep the 6 the same. 100,000, the number after it is less than 0, or less than 5. Sorry, it's a 0, so it's less than 5. So we keep the 4 the same and replace the rest with zeros. But just remember that you should pause the video and try those on your own. Like this next one, why don't you try it and then play the video. This one is, it looks like the decimal approximation for pi, 3.141592. And we want to round this guy to the nearest one. The ones place is right here. So the digit, we look at the digit after it, and that is, I shouldn't write that down yet, but the digit after it is less than 5, so we keep the 3 the same and we replace everything else with zeros. But remember, when it's a decimal point, you can, any numbers after the decimal point that are zeros at the end of the number just get dropped. So to the nearest tenth, we locate the 10th spot. So we can write our 3 point. We locate the 10th spot. The number after it is less than 5, so we keep it at 1. Right? Instead of making it 2, you would replace the rest with zeros, but then you can drop those. Only with a decimal, of course. The zeros at the end of a decimal number can be dropped. The nearest thousandth, so remember it goes 10th, 100th, 1000th, so this is the thousandth place. So we can write down at least the 3.14. And then when the thousandth place is a 1, we look at 5 or more, which means we add 1 to the 1 place, so that becomes 2, and then the others become 0, which we don't even need to write down for a decimal number. And the last one's 10 thousandths. Tenths, hundredths, thousandths, 10 thousandths. So that's a 5. So we can write down all the numbers before the 5. And we look to the right and we see that that number is larger than 5. So we're going to add 1 to this. So it becomes 6. And replace the rest with zeros, which we don't need to do. So that is just a reminder about rounding, which you'll have to be very efficient at rounding in this course. So there's just a little bit of problem solving with rounding. You purchased bread for $2.59, detergent for $2.17, a sandwich for $3.65, an apple for $47, and coffee for $5.79. Estimate the total cost by rounding to the nearest dollar. So the first one would round to $3. The second one would round to $2. The third one would round to $4. 47 cents is less than 50, so it would actually round to $0. And coffee at $5.79, that will round to $6. If you add all that up, it looks like the approximation is $15. So actually, we should use a squiggly for approximately $15. Determine the difference between the actual bill and your estimate. State whether your estimate is below or above the actual cost. So for the actual cost, we will add up those numbers. The actual cost. Right, well, you can use a calculator. Just make sure that you're using the scientific calculator that you're allowed to use for tests and quizzes, not a graphing programmable calculator. If you add those up, you should get 14.67. $7, 14, 19, let's see. And then it says this is the actual cost. So our approximation was actually pretty close to this actual cost. State whether the estimate is below or above. Oh wait, determine the difference between the actual costs and our estimate. So we can probably do that without a calculator. Looks like that is going to be 33 cents is the difference. And state whether the estimate is below or above the actual cost. The estimate was 15, the actual was 14.67. So the estimate is above the actual cost, but pretty close. If Bob made $20 an hour for 1 year, how much did he make considering he worked 40 hours a week but had 2 weeks of vacation? We're going to use two different methods. Just a standard method is one where you just sort of think about it, and then we have this unit where we cancel the units to get the correct units in the end. So the standard method, if he made $20 an hour for 1 year, how much did he make if he worked 40 hours a week but had 2 weeks of vacation? So if he made $20 an hour for each week, if he worked 40 hours a week, and remember you just multiply the 2 and the 4 together and get 8 and add the 2 zeros, 800. So he earned $800 a week, right? And we are not using 52 weeks because he had 2 weeks of vacation. So we do our $800 times 50 weeks. And again, you can do 8 times 5 is 40 and add the 1, 2, 3 zeros if you don't want to get out the calculator. So he earned $40,000. The unit canceling method is going to pop up later in this course, so maybe we will go ahead and use that. So he made $20 an hour. Whenever you see an hour, it can be written like this, $20 per hour. Right, and for 1 year, and so if you do times 1 year, and he worked for 40 hours a week, right now, you can see that in the end, we want to have our answer should just be in dollars. So right now, what we need to do is sorry, that was 40 hours a week. All right, 40 hours a week means 40 hours per week, so we want to write it as a fraction. So right now, what we have is you can cancel any units in the bottom with any units in the top. So right now, we still have years and weeks. So we know that we need to make that conversion. So what we need to do is multiply by something that equals 1, and 1 year in this case is 50 weeks. And we put the years on the bottom so that the years on the bottom cancel with the years in the top. And the weeks in the top cancel with the weeks in the bottom, because then we know that we have the appropriate units on our answer, which is just dollars. How much did he make? It just should be dollars, not dollars per year or dollars per week. So 20 times 40 times 50, you just multiply straight across, and there's nothing left in the bottom. So you know it's just 20 times 40 times 50, which is 40,000. I think this problem is straightforward enough to just do it using the standard method. But sometimes, you know, if you happen to take like a physics course or something and you need the units to cancel out, right, you can sort of figure out if you're supposed to be multiplying or dividing. Okay. person working 40 hours a week earned $54,200 a year. Estimate the hourly salary by rounding to the nearest 10,000 and estimating the number of weeks worked as 50. So this time we want to find the hourly salary. So we're going to take the total amount earned and divide by the number of hours. If we just think about it using a standard method. So we're just estimating. It says estimate by rounding to the nearest 10,000. So it's just something that we should actually be able to probably do mentally. So we're going to round this to the nearest 10,000, right? This is the 10,000s place, right? And so the digit after it is less than 5. So we're going to keep the 5 and change the rest to zeros. So if we round 54,200 to the nearest 10,000, that's the total amount earned divided by the number of hours. Well, the person worked 40 hours per week at 50 weeks. Again, estimating as 50 weeks. And then 4 times 5 is 20, and add 2 zeros. So you're just looking at 50,000 divided by 2,000, which is, of course, you can cancel the zeros, but you should see that that is 25, right? Remember, you can divide top and bottom by 10. You can cancel. So it's actually 50 over 2, and half of 50 is $25. Dollars per hour. All right, which I hope that you would just be able to do mentally. That's what estimation is for. 40 times 50, well, that's 2,000. Divide 50,000 by 2,000 to get the hourly salary. Use the unit canceling method. So we're given that the person makes 54,000. Well, it says rounding, so we'll go ahead and round that back to the nearest 10,000. 50,000 per year. And again, you want, in the end, you want it to be dollars per hour. So you're going to want to get rid of the years in the bottom. And you're going to convert, so you want the 1 year on the top, because the 1 year will cancel with the top and the bottom. 1 year is 50 weeks, right? Because then this will cancel with this. And you're always timesing, but you just have to figure out. So right now you're in dollars per week, and you want dollars per hour. It should be hour right there. I estimate the hourly salary, so we want dollars per hour. So 1 week is 40 hours. We want the week in the top so that it cancels with the week in the bottom. So now if we look at the units left, it's dollars per hour, which is what we want. So then you can multiply straight across. 50,000 divided by 50,000 divided by 50 times 40, which is 2,000. So that's 25, and then dollars per hour. Again, that may seem complicated, but we will be using that canceling idea later on. So I just kind of want you to get used to it. Remember that you can cancel any thing that's the same in the top and the bottom. So it will help you figure out sometimes what the operation is. If Kathy traveled between 5 and 8 hours at a rate of 40 and 60 kilometers per hour, estimate how far she traveled. So there's a couple different ways of doing that, but of course we know that distance equals rate times time. Right, so what kind of jumps out to me is if we want to find estimate and we're given a range for each one, for the rate, the range from 40 to 60 and the time 5 to 8 hours, maybe we would take the average of the two, right, for a good estimate. So if it's the rate is between 40 and 60, maybe we would average those. You could see that the average of those is 50. The number directly in between them is 50, but you could also do this. So we would use a rate of approximately 50 miles an hour, and time is between 5 and 8 hours. So maybe, again, we would find the average time. So you could maybe figure out that that's the difference is 3, so you would have to add 1.5 to the 5, so it would be 6.5. But if you want to, you can add those up and divide by 2. 13 divided by 2 is 6.5. And this, again, will show you, if you do that, 50 times 6.5, I'm going to show you too with the unit canceling. That's approximately, we're just estimating 325 miles. But you will see that you will get the right, and you have the units there at the end, but the rate is 50 miles per hour times 6.5 is the estimate for the hours. So you can see, again, if you cancel these, you know you're doing the correct operation because the hours in the top cancel with the hours in the bottom and leave you with miles. So you know you're left with miles as well. That's the unit canceling method.